next topic is trig. Everybody's favorite, right? Okay, I have to ask, who, in all honesty, would say they have no clue about trig? Oh, we're in trouble. Oh, we're in serious trouble. Okay, so trig is a necessity. If you need me to give you a YouTube video, I will. There's one out there, it's like hours long, and you just go to the bookmark that you want. Anyway, he did pretty good. I don't have a trig video, but I do have this. I am going to review one thing that you need, and then as we go through the course, identities are going to come up and other things that you need. But if you've never seen trig before, you're going to have to put a little extra time in. If you're just uncomfortable with it, get comfortable because it's here for the rest of your math career. All right, trig review. This is a table. You guys ever seen a circle? I do not believe in the circle. Because are you going to have it on the test? And how long will it take you to make the circle on the test? Yeah, you're going to kill your time. So I don't believe in the circle. I never teach the circle. When I teach trig, I don't teach the circle. I teach this. I want you to look at the angles. Where am I? Up until there. 0, 30, 45, 60. What quadrant are we in? We're only in the first quadrant there. If you know the first quadrant angles, you know all of them. How? Well, that's what I'm going to review with you right now. They're called reference angles. All right. So we have sine, cosine, and tangent. There are 3 others out there. They are reciprocals of these. We'll get there. They're coming. Don't worry. I don't want to overwhelm you with all 6 in one day. All right. Now, if I were you, I would recommend that you memorize this portion of the table. Tangent is easy to figure out if you know sine and cosine. Why? What is tangent equal to? Sine of theta over cosine of theta. So if you know the sine value, you know the cosine value, you can find the tangent. Or you can memorize it, and that's fine. But yes, at the very least, you have to memorize this portion of the table. These other 3 are actually special angles that really don't need to be memorized because the answers are based on where you are around the circle. Yes, I'm going to draw a circle, but I'm not going to fill in all the points. All I want to do is remind you of some angles. Where is 0? Up, down, left, right. 0 angle is on the right. I will be nice and put it in degrees. Do I believe in degrees? No, man. You'll have some application problems with degrees, but 90% of your problems will be, these are called radians. So 0 degrees is the same as 0 radians. All right, up, what degrees are we in? 90 degrees. Or, call that pi over 2 radians. On the left side, what degrees? I heard 180. Anybody know it in radians? Pi. And then if we go down, we're at 270 degrees or 3 pi over 2. Not only radians, but fraction. I know. And then if we keep going all the way back around, 0 degrees is the same as 360 degrees or 2 pi. Now, this is a unit circle. Do you know what a unit circle means? The radius is 1. So it goes out to 1 on the x-axis, 1 on the y-axis, -1 and -1. Now this is the x-axis and this is the y-axis. So when you think of sine, you guys know the answer is sine x or y? Y. And you think of cosine, you should think of x. So if you want cosine at 0 degrees, so that means you want the x value at this point. What's the x value at that point? 1. Which is why cosine at 0 degrees is 1. If you want cosine at 90 degrees, you're talking about the x value. Cosine is x. What's x up here at this point? 0. So cosine at 90 is 0. And then over here, if you want cosine, you're talking about x. What's the x value over here? -1. So we go to 180 cosine, we get -1. We go down, what's the x value? Or the cosine value? 0. Is that okay? Same thing with sine. Sine is just the y value at each of those points. All right, that's just a rough reminder. It's all the other ones that, well, I want to spend time on. They're called reference angles, is how we're going to find them. The basic angles can then be used, so by basic angles, I mean these ones here. These basic angles can then be used to find angles in other quadrants using what we call reference angles. For example, find the value of sine of 4 pi over 3 without using a calculator. Why is this important? Did y'all see the numbers in the table? Does the calculator tell you that answer? Does the calculator tell you that answer? Does the calculator give you a really annoying decimal number that's not exact? And our homework system and me wants exact. So you can't use your calculator. Okay, somebody has shown me a calculator that actually does this for you. So if you want to go invest in that one, anyway. But for the most part, yeah, you can't use your calculator to get exact answers, except for special cases. All right, so how are we going to do this? Well, first of all, step number 1, we need to draw a picture. So let's draw a table, or XY plane, I should say. Now, where is 4 pi over 3? What quadrant? Third? Well, let me help you out. You're right. Pi, if I want a common denominator with 3, you guys know how to do this? Pi is the same as 3 pi over 3. Then I need 4 pi over 3. So that would be 1 more pi over 3. So we are down here. This angle here is 4 pi over 3. It's 4 pi over 3 in my table. No, it was just first quadrant angle. This is not a first quadrant angle. So what we're going to do is we're going to find a reference angle. Reference angles are illustrated by this picture on the right-hand side. In the first quadrant, it is this angle here. In the second quadrant, it would be this angle here. In the third quadrant, and in the fourth quadrant. How do you figure this out, though? You take your terminal line, the point at the end. So, for example, here, the point at the end of the terminal line, and you draw a straight line to the x-axis. Or if it was this terminal angle here, straight to the x-axis. If this is your terminal angle here, straight to the x-axis. Straight to the x-axis. So can you see where our straight to the x-axis should be? We good? That's called your reference angle. This triangle right here, forming this angle. This angle here is what you need to know. What angle is that? You've already gone 3 pi over 3 around. How much further did you go? 1 pi over 3. Pi over 3, though, isn't that a first quadrant angle? So isn't that in the table? What's the only problem I might have? As you move through your quadrants, these are all positive numbers because x and y are positive in the first quadrant. As I move around, are x and y always positive? That's the only thing that could change as you move around the quadrants. All right, so what we're going to do is we are going to look at our reference angle on the chart, and we are looking at sine. So sine of our reference angle is equal to what in the chart? Anybody want to read that off? Right there, square root of 3 over 2. That is the reference angle's value. Step 3 is to check the sign. This might be your answer, or you might need a negative sign. All that depends on which trig function you're doing and which quadrant you're in. There's a little guide over here. We are in the third quadrant. In the third quadrant, sine and cosine are both negative. Tangent is positive. We want sine. So sine of 4 pi over 3, our angle, is equal to sine of the reference angle, but I know because I'm in quadrant 3, I need a negative. So negative, the angle answer that, or the sine value that we found, square root of 3 to 3 over 2. You have your circle and you have it memorized, you have another way, you can go for it. But in our system and on exams, especially multiple choice, it will be exact answers. So you have to know how to find these answers. If you need help with this circle, this is all students take calculus. The A stands for all. All trig functions are positive. The S stands for sine. Sine is the only positive. T stands for tangent. Tangent is the only positive. And C stands for cosine, being the only positive. So these letters tell you who is positive. You good? Try another one. What if I mess you up and switch from sine to cosine? Do I need to do all that work all over again? Look at the angle. Isn't that the angle we just did? So couldn't I use my resources wisely? I already drew the angle. So what's my reference angle? Still pi over 3. So cosine of 4 pi over 3 is equal to cosine of the reference angle. What's the only possible difference between these two values? Positive or negative. So we need to check. In the third quadrant, is cosine positive or negative? So we need to put a negative sign on it. Now, how do I find cosine of pi over 3? We memorized the table, right? You're going to between today and Thursday next week. All right, cosine pi over 3, 1/2. But we need a negative. If you would like to memorize tangent's reference angle, it works the same way. Or this is sine of 4 pi over 3 divided by cosine of 4 pi over 3. Sine of 4 pi over 3 we already found. Negative square root of 3 over 2. Cosine was negative 1 over 2. Can you simplify that? What can you do? There's different ways to attack it. What does this line literally mean? To divide. So how do you divide fractions? Yeah, so keep the top, whoops. Keep going to put a 2 in there. Keep the top times the reciprocal of the bottom. Negative and negative make positive. What do the 2's do? So we end up with the square root of 3. Tangent is positive in the third quadrant, so our sign matches what all students take calculus tell us the sign should be. Good. We're going to change the angle. Try one more time. This is the last angle, and then we'll start calculus. No, we won't. We're still doing algebra. But it's okay. We're getting to calculus, and slowly but surely. Calculus is foundation is algebra, so we got to do it. All right, what is our angle? Oh, I just turned it over. That's kind of cheating, isn't it? 3 pi over 4. Where is 3 pi over 4? What quadrant? 1, 2, 3, 4, 2. Well, this is pi over 4. This is 2 pi over 4. So this one must be, right? 3 pi over 4. How do I build my reference angle? Good. From the end of your terminal line straight to the x-axis. That, oh, wait a second, that's not part of my angle. It's okay. It's the leftover. if you've gone 3/4 of the way around towards pi, what angle's left here? Pi over 4. That is your reference angle. So sine of 3 pi over 4 is going to be equal to sine of who? Pi over 4. Except sine in the second quadrant. Wait, sine in the second quadrant, is it positive or negative? Remember, sine is the y value. Positive y-axis. So this would be a positive. So they're actually the same. All I need is to go back to my table and read it off. Anybody know what sine of pi over 4 is? Square root of 2 over 2 is correct. Do I need to draw a whole nother angle graph in order to answer cosine of 3 pi over 4? No. This is the same as cosine of who? I just have to check the signage. Cosine is x. So if you look over here at this point, is x positive or negative on the left side? Negative. Or you can use the circle. All students take calculus. Cosine is negative. So we get negative. What's cosine of pi over 4? The same thing as sine. Square root of 2 over 2. How do we find tangent? Divide them, yep. Good. But no, what do you notice? We have square root of 2 over 2 divided by negative square root of 2 over 2. These two are the same, so what happens? They cancel out and you get just one. Oh yeah, the negative sign, you can't lose that. And there you go. All right, that's my trig review. Yes, there's lots more trig you need, but evaluating trig functions is something that's going to come up in the first unit. So there you go.